Hello everyone, this is question number 3 from physics paper alternative to practical paper 6 variant 2 February-March 2023. Let's go to question number 3. This question is asked about electricity topic in your syllabus. Okay, question number 3. A student investigates the properties of resistance wire. How the length of the wire is affected in the resistance. As you know, as you remember and know, as the length of the wire increases, as the resistance of the wire, of course, increases. And you should know something else. What is the relation between the cross-section of the wire and the resistance? In this experiment, he asked about the investigation, how the length of the wire is affect in the resistance. He uses the circuit as shown in the figure. On the figure, draw a voltmeter detected to measure the potential difference across the length of the resistance wire. So be careful, guys. You cannot put the voltmeter at the beginning of the length wire because this is wrong. If you put it from this beginning, so this will be wrong answer because the question asks about the potential difference across the length only of the wire, which is represented and start from the crocodile paper clip until the other terminal or the other point in the circuit. Okay. Question number B, the student connects the crocodile clip and measure the volts and measure the current from the voltmeter and the ammeter as you see in this question, and read and record the number in the table, okay, and take the values as shown for different lengths of the wire. He measures the volts and ampere or the current by ampere by using different lengths of the wire, because the investigations here asks about what is the relation between the length of the wire and the resistance wire, and how the resistance is affected by the length of the wire. So as we said at the beginning of the video, as you increase the length of the wire, of course, the resistance of the wire will increases. Okay, so, and record the reading here in the table. When the length was 20 centimeter, the volts will 1.3 as given in this diagram. 1.3, you can zoom it and you can see the answer. Okay, this is 0.5 and this is 1.1, 1.2, 1.3, and the current here is 0.8, 0.9, and okay, this is 0.9, and so it will be the current will be 0.86 because this is 0.82, 0.84, and this is 0.86, 0.88, and this is 0.9, and then so the one division is represent 0.02. Okay, so the resistance can be calculated by using Ohm's law, R equal V over L. In the second part in the question, you need to plot a graph. The plot graph between the resistance as y-axis and the length of the wire as x-axis, as you see. So here, this is very simple question, I think, because the length of the wire is given in 20, 40, 60, 80, 100. So the length is the x-axis, 20, 40, 60, 80, and 100. And don't forget to write the heading or the heading columns for the unit. Okay, and the y-axis are per ohm. Okay, and the readings here 1.5, 3.6, 4.2, 6.6, 8.3. So I think taking the scale 2, 4, 6 is a good choice for this reading. Okay. To avoid any mistakes while you drawing the graph, okay, you can make a highlight or a circle with a pencil, okay, and you can omit it or cancel it, or you can rubber the pencil at the end of your exam, okay. To be careful ان انت بترسم بين ال L per centimeter and the resistance per row. Okay, here we have the plotting graph for different points. Okay, طبعا أنا I don't have a ruler here. You should have a straight line like this. Okay, this is a straight line. You can plot a best fit line here between 100 and 80. Okay, let's return it back again. Use this ruler. Okay, you can connect between 80 and 100 and okay, I think between this one, yes, this is the best fit line. Yes, so best fit line, so you should choose the best fit. طبعا أنا I don't have a ruler and in copybook طبعا في البيبر عندك هتبقى more accurate. أكيد, okay. So this is the best fit line, you can draw it in the exam. Okay, let's complete. The question number D, they determine the gradients. Okay, to remember the gradient can be calculated by delta y over delta x. So the difference between y axis, y2 minus y1 over x2 over x1. So the y هنا represented by the resistance and x is represented by the length. So take two different values here and I will get the gradient equal 0.085. Okay, I take these 2 points and you can take the gradient as I make it this experiment. Question double I, the gradient is numerically equal the resistance per unit length. So the resistance, and because the gradient, okay, is represent R2 minus R1, okay, you can use it like this, R2 minus R1. This is the first reading of the resistance, and this is the second reading for the Y, 6.6, okay, this is 6.6, and 1.5, okay. So the difference will be over the difference in the axis, in the x-axis, the 80 and L20. Okay, I take this one and this one. So the gradient here is numerically represent the difference in LR over the difference in LL. Okay, so the R naught or the R at the origin of the experiment, or the value which is represented here in this question is R naught, is the same of the gradient. Why this experiment is very difficult to make it in the lab? Because why the student دايما لما بيجي يعمل excess experiment may not obtain the same reading each time. why بيديله different values. ليه لما بيجي يستعمل الكروكودايل وياخد different lengths it's very difficult ان هو to position, to place, to put the crocodile accurately in the wire. صعب جدا انك تقدر تتحكم more accurate 100% انك to place the crocodile clip in the wire. Okay. Question number 4. This is the planning experiment. Inshallah, we will continue in the next video. Thank you for watching. Thank you and good luck.